The subject of today's webinar is redundant topologies in industrial OPC communications. Just a little bit about myself. I'm Dave Hammond, the Senior Product Manager. I look after the communications products here at M.A.C Solutions. So that's the Kepware, the OPC router, and the Cogent Data Hub software. All of those are OPC based middleware software applications. And M.A.C Solutions, we've been the Kepware agents in the UK since 2001, and we've been OPC router agents for about 6-7 years now. Looking at the agenda, we're going to be first of all defining a few things related to OPC UA clients, and then we're looking at various topologies where those clients are used. So a simple OPC UA topology, then dual path topology, dual path using simple clients, duty standby topologies, and then looking at how you can build your own duty standby functionality with off-the-shelf, more simple components. Towards the end, we'll be talking about the products themselves, which will be featured in the webinar, which is the Kep server software from Kepware and OPC router from our partner company in Germany, InRay. So just at the start, let's have a few definitions about clients and what they are. The most important thing to realize about OPC clients is OPC clients are the active party in a communication between OPC clients and OPC servers. So the OPC client is the one that initiates the connection to the OPC UA service. It's the one that says hello and to the OPC server. The OPC client specifies what data is read and what data is written, and also how from the data is read and written. So it's the OPC client that's really running the show. And if you have a well-behaved, well-configured OPC UA client, you'll get good, efficient OPC communications. One thing that people get slightly confused about is when I'm talking about the initiation of the session between a client and server, i.e. the client initiates the connection to the server. That has nothing to do with the direction of data flow. So it's just the initiation of the session. So once an OPC client has connected to an OPC server, data can flow in both directions. It's a little bit like analogous for me making a phone call to a colleague. Just because I've initiated that phone call to the colleague doesn't mean I can only speak and he can only listen. Once the call has been answered, then the session is active and data can go in both directions. So let's have a look at some definitions of OPC types. The first one is a simple OPC UA client. So here is an OPC UA client, and you can see it has one connection. You have one connection to a server, and that is a single configuration. So in that sort of a client, inside the configuration page of that software, you'd see the ability to put one set of data and one set of configuration data on. Compare that to what I would term a dual path client. So in that configuration software, you have the ability to connect through the light blue path and the dark blue path. So those you have an element of redundancy in terms of dual path. So the client has the ability to have two sets of data for configuration data. So that the light blue might be the default one. If the light blue path is not available, then the client would choose to switch across and try to get data through the dark blue path. So the client has the switching rules here. The client is the one that's initiating the connection either through the upper light blue path or the darker dark blue path. And that may be in order to reach a particular device or a particular set of data via two network paths or two different sets of cabling or those sorts of things. So that's what I would call a dual path client. So one would be the primary path and one would be the secondary path. And normally at the end of those connections, you'd have a primary OPC server and a secondary OPC server. So just to stress, it's important to realize that the switching between those paths is being done in the client. You can see there's no server in that picture. It's the path is dictated by the client choosing to use one path or choosing to use the other path. Moving on to OPC client page number 2, here we have what's called a duty standby pair. So here we have a type of application which is designed from the start to be fault tolerant. So you have the software running on across two pieces of hardware. So you'll have server A and server B. Both of those will have this OPC UA client configured and running. And the duty and standby pair of applications, or an application split into two there, there is synchronization between the two of them, and there's data, there's interaction between the two. So if the top application is duty and is the one active at the time, it will be communicating continually to the client. So should the client, the standby one, so should the standby one see that that data is no longer there, it can then kick in and take over the function of duty, assuming the duty application for some reason, or that VM or that hardware or whatever is no longer running. So that removes a single point of failure. It builds in fault tolerance, and those sorts of applications are specifically made in that way to run across a pair of servers in a cluster or something of that type. You'll notice in the diagram there, you can see there's a light red and a dark red path. These type of applications also tend to have the dual path capability as shown in the previous slide. When these applications are running, you can normally run them in several different modes. The common ones are hot, whereby the duty and standby are both active. The OPC client applications inside them are both active, both pulling data, and between the duty and standby application, the data is synchronized, and the application would decide which set of data, set A or set B, is the one that's going to be taken as the active set of data at that time. With hot-warm, you'd have the duty active and communicating and getting data, and the standby would be in standby mode, waiting to kick in should it see that the hot duty application is no longer doing what it's supposed to do and no longer responding. You then also have hot-cold, whereby the duty application server is running and doing all the comms and doing all the work, and the standby one is actually, the application is the server is actually active and powered up, but the application won't actually be initiated. So it needs a manual intervention to make that standby client to kick in and start doing the work. Okay, so let's having defined those OPC clients, let's look at topologies that adopt them and use them. Here you have a simple OPC UA connection. You have an OPC client. It's making a connection to an OPC server, and that server is communicating to, let's say, a PLC, and the client is making requests to the server. The server is fulfilling those requests by talking to the PLC, getting the data or writing the value, or whether it's read or write, and sending it back. A little bit about OPC UA, those familiar with it. For those people not terribly familiar with OPC UA, it's bidirectional, high security public-private key encryption is used. So the client has a certificate for the server has a certificate for the client, and therefore you have a very, very secure communications capability. It's not really, it's not open or anything like as open as the older OPC DA standards. And because it's not using the OPC DA standards, it's not relying upon the Windows security, it's using security between IP addresses using HTTPS and public and private key encryption and authentication. So for dual path connections, you have the OPC client making a connection to server number 1 through the light blue path, and making a connection to server 2 through the dark blue path. The OPC UA client is the one that's deciding which path to use. And you can see that there is no line between server 1 and server 2. Server 1 and server 2 don't communicate between each other. They're not aware of the presence of the other server. There's no interaction or synchronization or any sort of rules or switching happening inside the server 1 and server 2 here. It's the switching rules and all the decision making is all done by the OPC client on the right hand side. When you're considering the cost of doing this sort of dual path solution to remove a single point of failure down on the shop floor where the server 1 and server 2 would be located, you will need the relevant licenses for the KEP server 1 and KEP server 2. Now, if you want to do this sort of dual path redundancy, but you don't have an application that necessarily has the switching rules, has the ability to be configured with 2 paths, then what you can do is you can put a set of software in front of the client that will act as a proxy and provide it with that dual path facility. So this is the solution that we can provide using the KEP server software. So here on the right hand side, you can see you have the simple OPC UA client application. It is talking to a copy of KEP server. And in this particular case, KEP server on the right hand side, it is running on server number 3. It is acting as an OPC UA client, and the OPC UA client driver within KEP server has this dual path function. It's called media level redundancy. And the OPC UA client driver is connecting via the light blue path to server 1 or the dark blue path to server 2. The application on the right hand side is making a single connection to KEP server running on number 3. So server number 3. So it is only getting data from one path, and KEP server is then making this have the ability to connect to data using 2 different paths using the dual path function. So this is a simple one-step solution to give an element of dual path redundancy for an application you might already have, which simply doesn't have that facility. You can also achieve the same sort of thing using the OPC router software. It has the same capability. It has the dual path function, which is what's called the Enterprise Plus plugin. It also has the ability to act as an OPC client and an OPC server. So there's 2 different ways to do it using the softwares that we sell to provide this level of dual path communications. So let's move on to have a look at topologies that are used when you have a duty standby situation. So as we talked about before, you have the duty standby software application, which is running across a pair of servers, server A and server B. And the server is either making a connection, the duty server at the top is making a connection to server number 1 or server number 2. And if the duty was to fall over, the standby application at the bottom running on server B would notice that it's fallen over because we wouldn't be getting any data from that that duty install of the software, and therefore the standby would kick in, become the active application, and would then also have the ability to connect using server 1 and server 2 to get the data. So here we have an application that's built around resilience. It's built around no single point of failure. These types of OPC UA clients, that's what they're built to do, this sort of topology. But again, these types of applications are ones that are specialist, and you may want to build a solution like this with an application that actually doesn't have this capability. So how do you do that? So what we can aim for is a duty standby-like behavior using standard components that don't have this built in. So here we have a similar diagram to the previous one, but there's a couple of differences. The first one is server A and server B. They are running the OPC router software here, and they are doing the dual path down to server 1 and server 2. And off the back of them, you would have client number 1, and down the bottom, you would see the same sort of thing on server B, and you have client number 2. Now, since there's no interaction between these two pairs of clients, it's possible you'll have a situation where data will be duplicated. And this actually can happen if both of those servers are running hot. You will get data being into the client number one and client number two. It's then down to data deduping to take the duplication out of this, but that's not within the scope of this particular webinar, and we'll cover a little bit about that in a little while when we come on to some of the later slides. But it's possible to do this type of duty standby-like behavior, because at no point would you have data in neither client. Either client one will have it or client two will have it, and then you can amalgamate that data at a later time. It may well be that those clients have got an internal database, and you can do a database merge at a later time. If you want to do a true redundant topology, this is the end point. This is where you'll end up with a solution that truly is a duty standby, no single point of failure at each step. So down on the OT network, you've got a pair of KEP server servers talking to the PLCs, server 1 and server 2. In the DMZ, you'll have an instance of OPC router running on server A, and you'll have an instance of OPC router running on server B. By using the OPC router redundant function, you can actually get those two copies of OPC router to communicate between the two of them. So in the same way as you have an OPC client that is actually perhaps a SCADA system or a logging system or something of that nature, which is built to be a duty standby handoff application, the OPC router can fulfill that role as well. So here you have a situation whereby you might want this project to take data from the PLCs down on the shop floor and pass it up into an IT cloud, perhaps push it to an SQL database, maybe pass it to Azure or one of the cloud applications using REST or MQTT, or just passing it up into further business systems further up the tree. So here you have an OPC router A or OPC router B running as a pair. They know if the other one is active, they know if the other one is healthy. So there is proper peer-to-peer redundant negotiation between the two of them. And if the server A is healthy, OPC router A will be getting data from the left-hand side and pushing it to the database or pushing it to the REST server or pushing it to the MQTT broker. If the OPC router standby doesn't see that the duty one is healthy, it will then kick in and it will take the data from the left-hand side from the OT network from server 1 and server 2 and push it to the database, the REST server or the MQTT. But what you see here is you have no single point of failure within the DMZ or within the OPC layer. You have the ability to create an OT to IT data application, which is truly no single point of failure at any stage. So just a little bit about the products that we've looked at in this webinar. Many of you will have been already familiar with the KEP server software. For those of you maybe new to it, this is the software that's the world's #1 industrial data platform. There's KEP server has sold more OPC servers than any other manufacturer by a large margin. It's been around since 1994. I think the earliest version came out then, so it's been around for nearly 30 years. Very, very stable, high performance. We have applications with millions of tags in them. Vast majority of large manufacturers, blue chip manufacturers, will be using KEP server somewhere in their organization, and we can provide licensing that would do anything from a single instance of an individual driver to act as a driver of perhaps a SCADA system or something of that nature, or an individual installation, all the way through to something which is enterprise-wide, whereby you can have a license of the KEP server software that can be unlocked multiple times, and we'll have the ability to have all the functions all active at one time. You can use it at multiple layers. You can use it down on the shop floor, on the OT networks. You can use it in the DMZ, and you can also use it further up for interfacing between the DMZ and IT layers using MQTT and REST. For those people looking at this from an enterprise perspective, the enterprise versions have centralized configuration management. They have the ability to be programmatically configured using a single interface at the center. You can also interface with them using an API. So if you want to write your own application for adding and deleting and changing configurations, you can do that. And the enterprise version also has Active Directory integration for added security. On the south interface, on the device side interface of KEP Server, you've got over 150 different drivers, 3 user configurable drivers for various types of complex bespoke devices, a wide range of plugins, and you have deep diagnostics on all the upper and low interfaces. So you can see if anything's going on the OPC side or the MQTT side or the PLC side, you'll be able to see what's going on and be able to identify what the root cause would be. As KEP Server has become international, it's now supporting multiple languages. Certainly, it supports German. I believe they support Spanish. I believe they're working on other languages as well. I think French was one, and I think Chinese and Japanese were other ones that they're working on. The OPC router software, maybe less people on this webinar will be aware of this. This is software that we often sell on top of KEP Server in concert with the KEP Server software, because it fits into that vital space between the IT systems and the OT systems. It sits often in the DMZ, which is sort of the cultural interchange between those two departments. And it has connections on the south side using OPC to connect to the likes of KEP Server. And on the north side, it would connect to a vast array of different business systems using lots of different types of protocols. So it will be communicating using REST, MQTT. It would connect to SAP and MindSphere and Microsoft Azure and Amazon Web Services, IBM Watson, Oracle, and the list goes on, InfluxDB, lots of different types of applications you can build with this. It's graphical, it's intuitive to use, it's very stable, very powerful. And when it's running, when you've actually got your configuration and it's in the runtime, you can actually see the values graphically moving across the screens, moving across the links in real time. So it's a very powerful software. Like the KEP Server software, it's priced and licensed in a modular format. So you don't have to buy a license for the whole thing. You can buy licenses for just the bits you need. So in that regard, it's very much akin to the same model that KEP Server has for licensing on a modular basis. So thank you very much for your time, everyone. If you want to reach out with me with any applications questions, you can email me at dave.h@mac-solutions.co.uk. Our sales department is sales@mac-solutions.co.uk. If you need any quotations or anything of that for that nature, any topologies you want to discuss, this is where we come in. We can share a diagram and we can have a look at the topology and find out if it's possible to do it and what is the best way to achieve what you need to do.